Let's test the DPS3005 in our benchtop power supply. Setup for measuring noise. Got some very short leads with spade lugs. Scope hooked up to those very short leads. Running with the load that we made in the last video. Measuring on a Rigel 1054. And running Ultrascope Rigel software on a PC to monitor what happens. All right, here's the screen with the unit turned off. We're monitoring the DPS3005 power supply output. On the output pins, we have a 5 ohm load attached, and the unit's off. It's pretty quiet, so I think it's generally a good setup. Let's turn it on and watch what happens. When the unit comes on, the output is off on the DPS3005, but we do see noise appearing. And our vertical scale ultrascope shows divisions of 5 millimeters, but I really believe that those are set to 250 millivolts. I believe those are set to 200 millivolts, and you can see that down here at the bottom. Not quite sure why the Rigel ultrascope puts these particular values here, because I do believe the scale is 1/4 of a volt. So there's quite a bit of noise on the outputs, even with the DPS3050 off. Let's go ahead and turn the DPS3050 on and see what happens. Okay, we get quite a bit more noise coming out, and it looks like that noise is about 1/2 volt to a volt to a little bit more than a volt at times. So looks pretty noisy. We're not doing anything at all here other than wiring up with about 4 or 5, maybe 6 inches of cable between the DPS3005 and the jacks on the front panel, and just a 1 amp load. The DPS meter shows 1 amp at 5 volts and 5 watts being dissipated. So this looks like a pretty noisy output, even with the output on or with the output off. The output's on right now. Here's the output off. It takes a while because it's AC coupled to settle down, but even when the output is turned off, there's still quite a bit of noise that comes out the pins. And that might be conducted, don't really know for sure. Have to do some investigation here to figure out what's going on. Let's turn it back on. Takes a while to settle, and we're seeing quite a bit of voltage here, at least on the peaks. More than 1/2 volt, sometimes almost 3/4 of a volt. Here's one of those spikes caught on a single shot. Let's do a couple more single shots, but you can see the energy is about, let's see, we're at 200 nanoseconds per division, so it's not very wide, a couple hundred nanoseconds, but it's at least 1/2 volt, and we're on a 5 volt scale here, so it's a pretty significant noise. Let's grab another one. Sometimes they're louder, sometimes they're smaller. Just depends upon the one we capture. That's a small one. There we go. That's got a fair amount of energy and a lot of ringing. Okay, that one looks like it's even worse. A heck of a lot of ringing and a lot of energy here. Probably not a good thing to vary the 5 volts by 1/2 volt. Even it's probably going to be cleaned up a lot by whatever it goes to, but it does rely on the target having good capacitance. If we crank up the trigger level to 800 millivolts, we can catch some even larger impulses here. And again, quite a bit of ringing going on here. I don't know if we can zoom in anymore. Let's see if we can do that. Yeah, pretty fun. Definitely would be nice to clean this up. With the output turned off, we're still getting some of these, but they're not as energetic. This is just noise coming out of whatever's in the box. Not quite sure how much of it's the DPS, and it could be the other supplies, but we'll investigate and take a look at that too. I don't think it's the other supplies. I think it's the DPS that's doing this. Some of this phenomenon might be the fact that we're using a wire wound resistor, but I did notice something interesting. If I just grab the case and I hold on to it, I notice that noise goes away. So there's definitely a return path issues of some sort here with just general grounding in my environment. I see more noise on the scope than I'm seeing on the actual physical scope than I'm seeing on the screen here. If I bring that voltage trigger level down, what do I see? Well, I'm still seeing some noise. I disconnect the load. I'm seeing a different kind of noise, but still some noise. Reconnecting the load. This might be just a lot of it due to the way things are grounded here. The case not being grounded, and my other issues could be the fact that this is a wire wound resistor. That might be part of the effect. It might be almost the tuned circuit here. If I let go of the case and set everything down, definitely get a lot more energy in that impulse. Hard to gather a lot of conclusions at the moment, but let's see what we can look at. Well, let's try an obvious solution. Let's attach a 0.1 microfarad capacitor, ceramic, so it's got a nice low ESR, to the output pins and see if that gives us an improvement. This is with the supply off. It didn't kill it, but it looks better to me. Let's turn the 5 volts 1 amp on, and again, quite a bit, what looks to be quite a bit of improvement. Let's see if we crank up the level, if it's still there. It was there. Yeah, it's still there at a half a volt, so I think that would help. Let's take a look at making a little card to do that. I think that's probably the right approach. This has got a lot of wire leads, inductance, and it's a little bit messy, so if we can build that onto a cap with some other card with some other improvements, we might get a better result. I think there's a lot less energy here. It looks like it's getting damped out. Still got some issues going on here. I think the case grounding is going to end up being a lot of it. I just grabbed the case of the load again and it went away. So I'm really thinking that grounding the case would probably be the better gain. But let's try making a little cap card in this video. I'm going to order it from Osh Park. It'll take a while to get here. The cap card's a pretty simple design. It's got spaces for 4 capacitors. They're all surface mount caps, so they're nice small lead inductance. 10 microfarad is a nice bigger cap, and then 0.1, 0.01, and this one would be 0.001. Let me fix that. That's a classic technique for reducing noise. Put a series of caps on. Different capacitance values have a little bit different characteristic for noise, and spreading them out is a good way to do that. I've gone ahead and laid out a small card to do this. I want the width of the card to be such that if 2 cards were installed on the binding post on the back side of the power supply, that they wouldn't interfere with each other. The spacing between the cards is, or between the binding posts, is 3/4 of an inch, so it's 1.5 inches between sets. So as long as the card is less than that, and this is 1.19 inches wide, it shouldn't be a problem. There are slots here for the binding post connections, and those slots allow the binding posts to be holes in the chassis to be a little bit misaligned, because when you're drilling with the drill press, even if you center punch the hole or mark it to begin with, the bit will drift a little bit and things will be slightly off, so if it was too close it wouldn't work. For the other connections out to the power supply, I put what is essentially screw holes for number 4 screws, so the current cables could be disconnected from the binding post and wired straight down to these, which could have screws and washers and that sort of thing, and a stack up to just hook it up directly. Or 12 gauge stranded wire could be used to connect out, or smaller wire diameters, just have extra solder. The board's laid out with power planes, so the top level is the ground plane on the left and the VCC plane on the right with the split down the middle. The back layer of the card is completely all ground. This could be installed either way in the box. It would probably have to be installed with the, well, if it depends whether the card's mounted up or down, and really VCC and ground don't matter since the caps are non-polarized, so it's just notional here which one is VCC and ground. So I'll take a look. I think it would be nice to have the ground plane facing out of the chassis so that noise is suppressed that's might be present in the card. Switch back to the front layer. Okay, if I shut off the layers, it's just the 4 capacitors, and it's a pretty small little card. I went ahead and ordered 3 of them from Osh Park, which will take a couple of weeks to get here, so I'll put up a video and test them after I get it up here. I think they're going to add some value, although I think grounding out the case, as we saw in the last part of the video, is probably going to be the better answer. It looked like there was quite a bit of noise just off the way the case itself is not grounded to anything inside of the case due to the plastic frame that the panels and sides and everything bolt into. So I think that'll probably get the biggest bang for the buck, and this little card's just generally a good idea. It keeps noise from the device coming back into the power supply. And as I said, I've ordered 3, so I have enough for all 3 outputs. Here's the obligatory 3D view of the card, just the 4 capacitors. I increased the spoke size from the default 20 mils to 50 mils. It'll be a little tougher to solder these because there'll be a good heat sink into the planes that are next to them, but I think it'll help in lowering any inductance that might be present. Same thing with the binding post holes and the wire or 440 screw holes, either one. The way this box is made, it's not a solid metal box. If you look around the edges of the white pieces, you can see it's made out of plastic, and the rear and front panels bolt into plastic. The top lid bolts into plastic on the vertical side pieces there, and there's no metal connection between the lid, the bottom, or the front, or the back. I really think the biggest gain in getting this supply quieter will be had by scraping away paint and attaching ground leads to a single point frame ground connection. I think that'll make the box itself a lot quieter. It can never be perfectly quiet due to the fact it's got plastic around the edges, but I'm going to use that plastic to my advantage. This little DPS3005 has a Bluetooth module available for it. It also has a USB. I think I bought both, not realizing you can only use one at a time. And I'll probably try to dig that Bluetooth module out. And if I tuck it in one of these corners where there's plastic, then I don't have to worry about it being inside of a solid Faraday cage shielded metal box. It'll be able to communicate out with Bluetooth. I think there's quite a few videos up there on using it, the DPS series power supplies with Bluetooth. I never tried it with the USB when it was in the other little box, so I can't speak to how good the interface is for any of that. And I do think it's really probably, for my purposes, kind of useless and maybe a last thing I'll do of all, if I do it at all. But having the plastic might actually be advantageous in this particular case because we can get out through the plastic the Bluetooth RF signal. I guess the bottom line of this video is, even if you're buying off-the-shelf parts, you still need to make sure they're decent, good quality. Not that if you bought something that was built up that it would be much better. It might be a lot worse. I've got a lot of cheap benchtop power supplies in my lab, and they're all pretty crappy. I don't know if I did the same test on them, what they would look like. But doing your own testing and making sure that you characterize your test equipment is a pretty useful thing to do in any engineering environment. You definitely don't want to produce something that's going to put noise into your target, because then you're debugging the target noise that you've created from your benchtop power supply. and we'll see how this all goes. Thanks for watching, and hope you're enjoying this saga of making a benchtop power supply from commercial parts. It's going to always be fun. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.